Dear students, today we are going to discuss the concept that is the applications of differential equations. Now let us see here. First application that we are going to study is population growth and growth of bacteria. Means some questions related to the population growth and growth of bacteria. We will solve that. Now in that case, what is given to you? If the population P increases at time t, then the rate of change of P is proportional to the population present at that time. You know that rate of change of P means the derivative of P with respect to time. All of you know that rate of change means the derivative. So here if the population is considered as P and the rate of change of P is proportional to the population present at that time, suppose it is given to you, then mathematically this can be written as dP by dt is directly proportional to P. So see here, and that's why we get dP by dt is equal to K into P, where K is the constant of proportionality. And this dP by dt is nothing but the differential equation. So by which you will get, or you can use the application as a population growth and growth of bacteria. So here by taking the variable separable form of this equation, that is dP by dt is equal to K into P, we get the integration of 1 upon P dP is equal to integration K dt plus C, and hence the integration of 1 upon P is log P, it is equal to K into T, where K is constant and integration of 1 is T, so K into T plus C, where C is the constant, that is integration constant, and hence we get P is equal to e raised to Kt plus C. See, log P is equal to Kt plus C, that means P is equal to e raised to Kt plus C, that is equal to A into e raised to Kt, where e raised to C is considered as A. Means after using the given condition, we form the differential equation, and by using variable separable form we have to solve that differential equation to get the required answer. So overall this is the concept of population growth and growth of bacteria. So related with this we will solve some example. Then also there is a concept of radioactive decay. As you know that the radioactive substances like radium, uranium, etc. disintegrate with time. Disintegrate means the mass of that substance decreases with respect to time. So the rate of disintegration, that is called as rate of decay or decay rate of such elements is proportional to the amount present at that time. So mathematically it can be written as dx by dt is equal to minus kx, where k is the constant of proportionality. So the negative sign appears because x decreases as time increases. So again here also we get the differential equation. We form the differential equation by using the given information, and then we have to solve the example related to the radioactive decay of certain substance. So now today we will solve some examples from the exercise 8.6. So let us see. Now see the example. In a certain culture of bacteria, the rate of increase is proportional to the number present. This is given to you. If it is found that the number doubles in 4 hours, find the number of times the bacteria are increased in 12 hours. So this is the question related to that concept, that is population growth or growth of bacteria. So just you see this statement that in a certain culture of bacteria the rate of increase, means here the rate of change is given to you, and rate of change of that increase is proportional to the number present. So we have to express this sentence mathematically. So in answer, first of all I will consider that let x be the number of bacteria, let x be the number of bacteria present, number of bacteria present in a culture at time t. So first of all I have to consider the x be the number of bacteria present in a culture at time t. Okay, and as per this given condition that in a certain culture of bacteria the rate of increase is proportional to the number present. That's why mathematically by given, how will you express that? Rate of increase means dx by dt is proportional to number present. Number present means here as we consider it as x. So dx by dt is directly proportional to x. Okay. So by that first statement we will express that first statement as dx by dt is directly proportional to x. Now further we have to choose the proportionality constant. So dx by dt is equal to, we get k into x. So this is the differential equation, and now we will use the variable separable method to solve this. Now here it is dx and dt. So in place of that dx we will transfer this x. So we get 1 upon x dx is equal to k into dt. So x is on the left hand side and t is on the right hand side. Now integrating we get integration of 1 upon x dx is equal to k into integration of 1 dt. So always you remember that by the given condition you have to consider dx by dt is directly proportional to x, then choose the proportionality constant, then use the variable separable method, and then you will get the solution of this differential equation. So what will you get after this step? Integration of 1 upon x is log x, or you can write log of modulus of x, or just you write log x, okay, is equal to, here you will get k into integration of 1 is t, plus we have to write the constant, integration constant. So this is very important. So here this is called as the general solution, GS, and say it is equation number 1. Now always you remember that in such type of question, after getting this general solution of that differential equation, the next statement that is given to you that if it is found that the number doubles in 4 hours. So initially what will be the number of bacteria present, that you have to consider. If it is not given to you, because it is here given that the number doubles in 4 hours, this is given to you, but doubles of what, that you have to consider. So always remember, here the main step is what, you must know the initial condition. Initial condition is important. Okay, so this is the main part of the any question of this type, remember. So here it is not given, initial condition is not given. So we will consider that when t is equal to 0, initial condition means when t is equal to 0, what is the value of x? X means number of bacteria. Here we will consider it as suppose x0, because it is not given to you. So when t is equal to 0, x is equal to x0. This is always remember, this is called as initial condition. Now if you put this value here, then what will you get? So equation number 1, from equation number 1, what will you get? See, log of x0 is equal to, because x means x0 is equal to k into 0 plus c. That implies c is equal to log of x0. So now onwards you always remember that after getting the general solution of the differential equation, use the initial condition and then obtain the value of C. Now as you get the value of C, then equation number 1 becomes, see, after getting the value of that constant, equation number 1 becomes, now you can write it as log x is equal to k into t plus, in place of C you can write log x0. Now this is after getting the value of constant. This is nothing but the particular solution. Remember, general solution and particular solution. Now you can modify this as log x minus log of x0 is equal to k into t. That means you can write, by logarithmic rule you can write log of x upon x0 is equal to k into t, and this is the particular solution. Say this is equation number 2. This is very important. This is the particular solution. Now after getting this particular solution, now we will use the given part. Okay, so see this equation number 2. Now given part, what is given here? See, the number of bacteria, see here, I will show here that it is found that the number doubles in 4 hours. So how will you write the given condition? So when t is equal to, given that when t is equal to 4 hours, the number doubles. Now first, that is x is, we have considered x as x0. Now number double means it is 2 times x0. Now if you put this value in equation number 2, put this value in equation number 2, that is the particular solution, then what will you get? We get log of x, x means 2 times x0 upon x0 is equal to 4 into k, because t is 4, t is equal to 4. Now by this we get log of 2, because x0 will get cancelled, so log 2 is equal to 4k, and hence you will get the value of k, that is 1 upon 4 into log 2. So this is very important. After using the initial condition, we get the value of C, and hence we get the particular solution, and after using given condition we get the value of k also. Now rewrite the equation number 2. So hence after getting the value of k, equation number 2 becomes, what will you get? Log of x upon x0 is equal to, value of k is 1 upon 4 into log 2, and here it is t, so k into t, that means you can write t upon 4 into log 2. Okay. Now after this, what we have to find out? By using given condition, we have to find out the number of times the bacteria are increased in 12 hours. How many number of times the bacteria are increased in 12 hours, that we have to find out. So that means after getting this equation number 2, we have to find out, now our main question here, we have to write the answer. What we have to find out? We have to find out x. Remember, when t is equal to 12 hours, remember, when t is equal to 12 hours. So use this equation now. So log of x upon x0 is equal to, now t is equal to 12, so we get 12 upon 4 into log 2. Now what will you get after this? See here, just we have to compare both the sides. So log of x upon x0 is equal to 3 into log 2 or you can write 3 into log 2 can be written as log 8. Log of 2 cube means log 8. Now comparing both sides, what we get? We get x upon x0 is equal to 8. That means x is equal to 8 times x0. So by this mathematical relation between x and x0, x0 is what? X0 is considered as a initial number of bacteria present, and after 12 hours value of x is equal to, we get it as 8 times x0. So as a answer, how will you write this relation that x is equal to 8 into x0? Means we can write the number of bacteria will be 8 times the original number in 12 hours. So this is your final answer. Okay, so try to solve this type of questions related with this concept. Okay, see the answer complete. Here in this total answer, you have to consider first of all the differential equation, solve that by using variable separable method, very simple, and then use the initial condition, then use the given condition. By using initial condition you will get the value of c, then by using given condition you will get the value of k, and after getting that rewrite the equation number 2 and then write the required answer. So this is the typical format of this all these type of questions related to applications of differential equation: initial condition, then given condition, and then what to find out. Remember this one, and this one. So there are three steps, three important steps that you have to remember. Okay, thank you.